do them? You don't want to see them?
Not really.
Not really? Well, too bad. I'm going to do them now. You can see if you got them right or wrong.
Sorry, I just like making kind of announcement that I do like an email. So like, I know how to like break now. What how many meetings like 1:15 to 2:15?
What's this?
So Dr. Mark.
Oh, is that 1:15?
Yeah. Till 2:15. So,
And then what do you have at 2:15?
No. Then break starts by 2:15. Then academic starts by 2:15.
You have a half an hour break. Okay, well look, as soon as we'll get this finished, we can if we finish early, we're early, okay? We'll just get through this quickly. So that,
We have to
yeah.
attend that?
huh?
Like we have to attend.
Oh yeah, it's a health talk or something, I don't know. You have to attend, I don't, so I'll be eating my sandwich thinking about you as you're there. Okay. Did you only get that email today? But was it not marked on your timetable already?
It is.
Are you sure? Look, it doesn't matter. Look. We get this done quickly, we'll finish early, okay? So, let's get started and let's do this quickly. If you have your calculator handy, that'll be helpful too. Right, first question. A pipe for transporting oil is to be constructed from short steel pipes joined end to end. Each pipe has a circular cross section as shown in the diagram with internal and external diameters of 1.1 and 1.2. A crane is used to lift the pipes and is limited to 15 tons. Show that the maximum allowed length of each pipe is 10.6. Okay, couple of ways to do this. So basically we know the mass. The mass has to be 15,000. And we know density is mass over volume. So we know volume is mass over density, which is 15,000 over, thank you, Rahman, 7,800. And so what must the volume be? 1.92 meters cubed. Now I wonder, how many people took the first question as 2 cylinders or as one rolled out rectangle? What did you do? 2 cylinders, 2 cylinders, 2 cylinders. Both answers I'll accept. If you did it, if you rolled out the cylinder or if you took it as 2 cylinders, both are fine. Which was the majority way? So 2 cylinders, do you know what I mean by 2 cylinders? Like a big cylinder and a small cylinder, or a rolled out cylinder? 2 cylinders? 2 cylinders? 2 cylinders? 2 cylinders? 2 cylinders? Okay, 2 cylinders, fine. Oh, okay, fine. 2 cylinders it is then. Right, so we have the bigger cylinder, which is pi or squared minus, times the height, minus pi or 0.55. Because what is it? 1.1 squared times the height equals 1.92. So it's just going to be 1.92 divided by this. So, thank you. Yeah, and Marwan, you can double check too. And that's question 1. Okay, so I feel like question 1 went quite well.
This one, you are only marking the answer.
Yeah. It's
Just how to prove
No, like, you are not marking the steps, you are only marking
well, for question 1, I kind of have to mark the steps because you already know the answer. The answer is supposed to be 10.6. Okay, if you got that, then give yourself a tick. What property do vectors have that scalars do not?
direction.
Good.
If you just put direction, that's the answer.
Yep, fine. Yep.
But if you define both of them,
No extra marks. State which of the following are vectors. So velocity, yes or no?
yes,
Energy?
no,
Force?
yes,
Pressure?
no,
Yeah, it's some 50-50 on it, but I said before that for this course we don't take pressure as a vector, we take it as a scalar. And acceleration?
Yes.
It's a vector. Good. Right, question 3. You've got this diagram, and this is 25g. This is f. This is 600 cos theta, and this is 600 sine theta. So by saying up equals down, you can end up getting theta equals sine inverse 600 over 25g. Is it 24? 24.126. So I need to see 24.1 degrees. And if you sub this back in here, because this is equal to f, you can get the f. So what is 600 cos 24.13?
547.5.
So 8. 548 newtons. 548. Okay. Continue. Yep. Right. So far, no big problems, right? A ball is thrown vertically upwards at 18.6 from a height of 0.785 above the ground. Determine the maximum velocity. Right. So U is 18.6. V, don't know, is what we want to know. A, minus 9.81. T, we don't know. And S, good man, 785, minus 7.785. And we're looking for V and also T. Yep. V squared equals U squared plus 2AS. I should have given you more questions. These are too easy. So the answer is 19. And then I want the T, so I can say V equals U plus AT, and we can easily get the T. What do we get for the T? It's going to be 18.6 minus 18.6 minus 19 over minus 9.81. I guess it depends if you took 19 or if you used a different formula to get the T, like S equals, yeah. Actually, that's probably what most of you did, was it? No, you used V? But did you use minus 19?
No, 19 and the 18 was negative. So it would be 18 plus 19.
Oh, yeah, so it's wrong. You need to use minus 19.
You need to use minus 19.
Yeah, why?
But you still get 3.83 as your final answer.
Did-
If 19 is positive, but 18 is negative, and
You had positive 19 here, and then here?
negative 18.
Why'd you have negative 18.6? Why'd you?
Like it's coming down, so then the
Okay, I think you got the right answer for the wrong reason.
But when you are minus 18.0,
How should I explain
the
now?
3 is positive.
Yeah, the 3 will be positive
The
if
3
your
is
acceleration is also.
But the acceleration is downwards, is negative.
But your answer
But
was
you
negative.
assume it's positive.
You said we
Saying
should.
it's
Okay,
negative.
it's
should
fine,
be
yeah.
consistent.
Yeah, and you were consistent,
Yes,
then it's
so
fine.
don't
Then it's
keep
fine.
it, it's something else.
It's fine. It's just really, okay, it's fine. Right, 5. What's the maximum velocity of the sprinter here? Okay, so, yeah, it's a half the base, which is a half times 4 times the height, plus, and then the other area is 20 times V. That should equal 200. Ah, easy peasy, easy peasy. Blah, blah, blah. So easy. I should have given you many more questions. A car of mass 1400 is travelling at 24 and there's a force of 4200. Calculate the deceleration. That is equal to minus, well, because I say D, I don't actually care about the minus. 4200 over 1400. 3 exact? Yeah. That's the deceleration. And what's the distance? Well, no.
No, it's the second part that you said.
Yeah, the first part said what's the magnitude. No, the distance travelled. S
Wait,
equals?
so if you put -3, you fill the first part?
Yep.
Thank God.
Yeah. Because I question what is the magnitude.
I didn't do that. No, I'm just asking.
Just asking for a friend, right?
No,
Yeah.
my friend and teacher.
I have a friend who put a minus in. What would happen if they did that? Yeah. Did you really put the minus or not?
No.
Good man. Okay. Right. B. How do I get the S here? What UT? No, we don't know the T, do we? V squared.
Yeah.
V squared equals U squared plus 2A S. Oh, that's it, isn't it? So 24 times 24 over 6, what's that, 96 meters. Good. 7 is a description. You want to describe what happens to the ball bearing as it's dropped into some oil, isn't it? So what happens? Well, you drop the ball in and gravity pulls it down and causes it to accelerate. And this causes the ball to gain speed. However, as the ball is gaining speed, what happens? The drag increases until the drag equals the weight, and then what happens? One sec. Until the drag increases and equals the weight, and then what happens? Yeah. So, in a sentence, it falls at a constant speed. Did you say A equals 0 in your answer? Okay, fine. Didn't want to write a sentence?
I wrote a sentence, but I think at the point
Okay, fine. What were you asking me?
So number 6, he said like while the brakes were being applied, is it from when you started applying the brakes or from the start of the journey?
What's the difference? The car's going at 24, then the brakes are hit and it decelerates.
No, the distance traveled after he started applying the brakes or from when he started the journey. As in like,
Well, tell me what time they left their house at, and then you could work out the journey. Like, what are you asking me?
don't worry.
You can't get the total journey here. We only know about the braking part of the journey. All right, right. 8. A projectile is launched horizontally. After launch, it takes 0.7 seconds to travel 50 meters to hit a target. Is it like this?
Yeah.
Yes.
Oh shit, yes.
What? It's 50 meters here, isn't it? Oh, okay. So the first thing is they want the horizontal speed here. So it's constant. Distance, speed, which we don't know, and time, which we do know. What is it? Thank you.
So will you get a mark for this answer?
71.4. Yeah. Determine the vertical distance fallen. So that's this distance here, S. So we'll say S equals ut, which is 0, and then a half a t squared. 2.4. Before the projectile is launched, it's accelerated. Calculate the acceleration. So what happens is someone gives it a little force to accelerate it from rest, gives it a little push. and I want to calculate this acceleration. So we could say v squared equals u squared plus 2as. Right, yeah? A is...
We put the time like that.
Oh, sorry, thank you. The v is, no. Why are you confusing me?
A is
71.4, yeah, sorry. So the A is 71.4 squared over 0.8.
is
637.
okay.
A tennis ball of 57 grams travels towards the tennis player at 35.5. The player hits it so that it leaves the racket at 40.5. What is the average force here? Delta P over delta T. The time, do we know? We do. The mass, do we know? We do. The sign I don't really mind about. I'll say it heads to the left to begin with. Then it heads to the right. It heads to the right to begin with. And then heads to the left afterwards. Okay, so what do we get here? What is the impulse? Well, actually, we've worked that out already. It's the numerator here. So, what's that? 70 something, is it? It's just the number on the top.
4.6.
Oh, sorry, 4.6 kilogram meters per second. Define moment. So, moment is the turning force, which is the force times the perpendicular distance. Yeah. It's okay, we know it. If the load being lifted is 10 kilonewtons and the distance is 10, what is the moment? 10 kilonewtons times 10 is 100 kilonewton meters. Yeah? Yeah, fine. Yeah. If 10 kilonewtons is the maximum load and the distance is 30 for the maximum, what is the maximum, what's the distance when the load is 20? So look, it's 10,000 times 30. That's the maximum turning force. That has to equal 20,000 times d, yeah, or x. And so what do we get for d? Well, 15 meters, is it? Okay. Meters. Did you say centimeters? Oh no! Dun dun dun. That's going to cost you a mark. Yeah. How many construction cranes do you see that are 15 centimeters long on your day-to-day life? Maybe, okay. Well, actually, yeah, check out for you. Are you Abdul Rahman Al Saidi? No. Are you? Let's have a look. Centimeters. So tragic. Don't know. See what mood I'm in. Okay, 11. A uniform. I know why you did that, because usually these questions are centimeters, because it's usually a ruler, isn't it? Yeah. A uniform plank of wood AB of mass 20.5 and length 2.35 is placed at the pivot, 1.31 from the end. A child of mass 18.6. It's okay. So everything's on the picture here, isn't it? Except no, everything's on the picture. Except the lengths, yeah. And what do I ask you for here?
The distance from the child and
Determine the position of the second child from end B. Oh, that's the 25.3 one, is it?
5.3.
Okay, so let's draw this here. There's the pivot, and there's a child here at 20, and that's 25.3 G, isn't it? And then this is 20.5 G, and this one here is 18.6 G. Now let's get the distances. This distance here is, we'll call it X. Yeah? This distance here, do we know this one? And this I basically I want to know these three distances. Do we know where this pivot is?
Yes, it's at 1 point.
Is that 1.31?
Yeah.
Okay, so
And we know the beginning.
oh, so that's 1.31 then. Yeah.
We know the beginning is 0.
This is 0. Oh yeah, so
1.31
1.31 minus 0.823. What's that then? 0.487, is it?
Yes.
And then the last one we need is this one.
1.3 minus 0.4.
Do we know it?
Yes.
Oh, of course, this is the center, isn't it? So it's a
1.3
half. It's a half of 2.35. Yeah, and so what do you get? 135. Yeah. Okay, so actually, why did I write 1.31? I did. There's nothing here. Sorry. So it's 18.6 G times 0.487 plus 20.5 G times 0.135 equals 25.3 G times X. We might as well get rid of all the G's and then divide by 25.3. But I don't think it's the X that I wanted. I wanted this distance here.
So you do that minus
Yeah.
the other.
Yeah. So what do we get for X here? 18.6 times 0.487. Marwan, could you type this in? 18.6 times 0.487 plus 20.5 times 0.135 all over 25.3. What do we get for X, Ming? What do we get for X? Yeah.
Yeah, 0.467, is it? Yes.
Okay, but that's the X, isn't it? And we wanted this. So, what do we get for this length then?
You do.
It's 2.35 minus 1.31 minus 0.467.
0.7.
Thank you. Okay.
I made a mistake. Shit. Yeah, I used the half. I got 0.7. I got 0.7. Shit.
Yeah. Same mistake.
Is that what you're marking the last answer only?
Yep.
Shit.
Right, next. The diagram shows a climber resolve the forces vertically. So the forces vertically would be, guys, come on, T1 cos 40, isn't it? Plus T2 cos 50. And that should equal 75.5 G. And then horizontally is T1 sine 40, yeah, equals T1 T2 sine 50. And then we have to solve for T1 and T2.
Make T1 some length.
And sub it in. Yeah. But if you can you hand me up your calculator, Paolo? Yeah. Yeah, you could do some simplifying. Let me just check here. So, right, T1 is 567 newtons, and T2 is 476 newtons.
Yes.
Seems familiar?
Yes.
So how many were there? One in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23.
Is the man final answer?
I'm sorry, man. Sorry. Look at how sad you all look. Why are you so sad? You get to have your lunch 6 minutes early today. Right, off you go.
You can give us 6 more.
Here you go, Banno.